Hi, TLCers. Welcome to another great conversation. Longtime member and frequent guest host is here, Chad Sanderson, and he's going to be talking to us about various different myths and experimentation that need to die, because that felt like a really good topic for Valentine's Day. So thanks for being here, Chad. A reminder to everybody on the phone, if you are, everybody in the call, if you have any questions, please use the TLC calls channel in the TLC Slack. If you can't get to the Slack, you can use the Zoom chat, or take yourself off mute and ask your question. Another reminder for those of you who haven't subscribed, if you're in the TLC Slack, you'll get in the recordings channel a link to all of our prior conversation recordings, but you can also go directly there to the YouTube channel. And up here in the banner, there's this link to the Code of Conduct. Signing the Code of Conduct is how you get regular invites to these conversations, and also your invite to the TLC Slack. So if you haven't signed that Code of Conduct, please do so. And if you want a direct link to it, just send me a message through Zoom or Slack. All right, shall we get started, everyone? So first I want to introduce Chad. I'm going to hand off the screen share to Chad after the introduction. So hope you got your session up, Chad. But Chad is now the head of product and data platform at Convoy. I've put all the different places that he's worked, because in the time that I've known him, he's worked at 4 of these 5 places. And he's, added huge experimentation subject matter expertise to each of the companies and learned from all of them. And he's going to share a lot of that with you today. He's truly one of the experts in the field around how we think about, or should think about, the analysis of your test results and what they mean and all of that jazz. He's a true, can I say statistician? But he really gets the math, and he can explain it in a way that everybody else gets it, which I think is truly powerful and helpful, and the reason I keep inviting you back. So thank you for being here. And let me stop share and let you take over the share, sir.
Okay, great. All right, should do this here. And then I need to start this presentation.
Present in the top right.
Oh, it's being covered by my
screen.
There you go. Okay, great. Oh, thank you for that awesome review of me, Kelly. I appreciate that.
Absolutely.
And also the much better intro slide that I put together. So, hey everybody, my name is Chad Sanderson. I am currently the head of product for data platforms at a company called Convoy. If you've never heard of Convoy before, it's a pretty interesting business. It's a late stage startup at this point. They just got a $400 million funding round, Series D, last November, growing a lot. Around 75% of the headcount has come in the last year alone, so expanding really, really quickly. And what they focus on is it's basically the eBay for truckers, or eBay for freight. So traditionally, if a shipper like Starbucks or Walmart had a piece of freight that needed to be moved, they would contact a brokerage agency like a C.H. Robinson or J.B. Hunt. You may have seen those trucks on the road. And those companies would have a literal person with a black book full of truckers' names that they would call on the phone one by one to find somebody to accept that load at the right price and the right time. And we're automating that process. So it uses a lot of machine learning to match the best possible truck drivers to the best possible routes, and bundle loads together. So it saves truckers time and cost and carbon efficiency and all these other great things. So we are a very, very heavy ML and AI centric business. And so experimentation is something that is super key for us right now. And it's a really interesting place to be because Convoy is experimenting on small samples of users. So how can we best run A/B tests when we have very small populations is kind of an interesting question. In the past, I've also worked in an experimentation capacity, as Kelly said, at Microsoft and Subway and Sephora and Oracle. And uh, something that I was doing this year was starting to think about where is the future of experimentation as an industry headed? Where are we going, right? And there's been a lot of different companies and SaaS tools that have made predictions about what the future is, whether it's personalization or whether it's infused artificial intelligence or whether it's some new really fancy statistical algorithms. And that's great. But what I wanted to do was take a step back and since the industry has existed for some time now, look at some of the best practices that pretty much everybody follows and may take for granted and say, with all of our new knowledge, have we gone back yet and re-examined the past, re-examined the ways that we're doing things and ask if we're still moving in the best possible direction. And so when I was putting this presentation together, I really asked two fundamental questions over and over and over again whenever I was thinking of a best practice. And the first one was, how did we get here? And the second is, what is the extent of our knowledge around this particular best practice? So how did we get here is about the history, right? What are the historical reasons that we ended up where we are? Who said this best practice? Where did it first start from? And then what is the extent of our knowledge is what is sort of the point in time when we lose the concrete facts and we start drifting more into our assumptions. So I think a good thing for you guys to keep in mind is as you're approaching all the best practices that I've covered here and any more that you're covering within your particular disciplines, ask these two questions as well, and you'll probably arrive at some very interesting answers. So let's start with the first question of how did we get here and what's really motivating this conversation to begin with, and that's what stakeholders expect from A/B testing. Does the expectation of experimentation actually match what they've been getting? I think that's a pretty fundamental question to start with. And a visualization like this, which I took from a very prominent A/B testing tool, is I think kind of a clear sign of how A/B testing was sold to stakeholders and business leaders, right? So you've got these two sort of diverging lines. The red one is without A/B testing, you're essentially going to be stagnating on whatever this particular metric is. I guess we can just assume that it's revenue, maybe a slight increase, but it's going pretty slow and you have these major dips and valleys. But if you are doing A/B testing, then you get this really nice linear growth over time, and across a 6-month period you'll start to see these paths diverge quite significantly, right? Like that's sort of the dream, that's the vision that was sold. And yet at all the companies that I've ever worked at, including some of the biggest companies in the world, like Microsoft for experimentation, and a lot of other companies I've worked with that do experimentation, like Amazon, the actual graph looks something more like this, right? So you have that ideal world, cumulative results that all the product teams and all the optimization teams are reporting. Hey, we added $5 million in value with this test. We added $500,000. We added $10 million. And you get this nice linear curve, or this nice linear trend. But the reality of the business is flat. Your P&L people are looking at revenue over time and they're not seeing the linear curves that we're saying there are. So what's going on here? Why is this happening? I find that a lot of optimization teams aren't even really asking these questions of finance folks. They're sort of, it's running on faith that what we're doing is adding value. And I think that this is probably the #1 most fundamental problem currently with the A/B testing industry, is that it's really, really difficult for us to tie back the impact of our improvements to the bottom line of the business after a year, right? And so that's what sort of started that is the impetus for this presentation. Is there anything that we're doing wrong that's causing this? And I find that most experimentation professionals, the first place to point the blame is at the people running the experiments, right? It's at the people that are doing the tests or coming up with the ideas. Maybe not if you're an agency because you're doing that, but if you're using a platform, then that might be the case, right? They're either looking at experimentation the wrong way, or maybe they're expecting too much from experimentation. So I think now is another good time to ask that question: how did we get here? So I went back in time, and if you were sort of doing experiments over the past few years, um, then you will see some articles like this sort of pop up, right? Randomized controlled designs, it's the gold standard for knowing what works. It's the gold standard of evidence, the randomized controlled trial. So if you haven't heard of this term, the gold standard, basically what that means is that it's the best possible way that we know of doing something, right? Whatever that particular something is. And so the question is, what are randomized controlled trials the gold standard of exactly? And here's a whole bunch of examples of that from the industry, from articles that were written. So the gold standard, it's the gold standard for learning cause and effect in scientific research, right? So okay, well that's fair. Maybe that's actually true. Here's another one. It's the gold standard for measuring the effectiveness of changes to a website, right? So we're saying that A/B tests are the best way to measure whether or not a change is effective. All right, that's a pretty big statement. Gold standard of online optimization. It's the gold standard in strategic decision making. So now it's the best possible way to make any strategic decision at all, right? Nothing else is better than an A/B test for this. Gold standard for evaluating new product strategies, and it's the gold standard for eliminating biases, right? And so some people might look at this list and go, oh, okay, well this is pretty crazy, right? There's no way that it does all of these things. And there might be some people who say, well, no, this is pretty accurate. It does do these things. But whatever the case, this idea of being the best possible way to know what's working on a website was reinforced through the products themselves. So for example, you have a results page, an analysis page over here on the left that says your test results. Test B converted 34% better than test A, and I'm 99% certain that the changes in test B will improve conversion rates, right? So we're committing to that idea that was sold in the articles. That's the commitment, is we know what's working, and that if you do an A/B test, that's really the only way that you can know what's working. And you can look at all of these examples to see very, very, very similar language, right? So if you look at the one on the right, chance to beat the original, 0%. There's no possible way that it could be better. You see a lot of things like chance to beat the baseline or chance of improvement with these really, really high percentage ratings, and it's 100% and has check marks and things like this. So again, this might be something that you look at and say, well, okay, the products were kind of overselling it. I know a little bit about statistics, and I know that you can't make promises like this. So they're doing it wrong, but internally we're doing it right. So let's look at something that's maybe the language is a little bit more statistical. Maybe it's a little bit nicer. So up on this example at top, this is another product, right? And now it's using confidence intervals. It's saying, hey, we've got this sort of 10% change, and there's this confidence band for our B, for A, and then for B, the band is actually outside of our it's outside of the control significantly. It's an 11% change, and we're 95% confident that the result is a consequence of changes we made and not random chance, right? Okay, so, all right. So maybe you're not okay. Maybe even that's too strong. Maybe this is not actually what the statistics are really saying, right? Like if you know statistics, then you might be cringing at some of these, but maybe not. Maybe you see that and think it's fine. So let's take it another level deeper. Now let's say, well, let's just look at the numbers, right? We don't want to put in these levels of interpretation, these abstractions, and talk about confidence, because people may see that and believe it's a real winner when it might not be. So let's just use things like p-values and confidence levels and relative changes, right? Let's just use the flat number, the p-value itself, 4.56447 e to the negative 10 there. So basically it's 10 zeros and a 4. That's how low the p-value is, and then we can be really, really confident in the change. And I saw all of these products, and I've even worked with products like this internally. And something about them made me feel a little bit strange. And I wondered if what was being advertised here was actually matching to that original expectation, right? It was matching to that gold standard of being able to make strategic decisions. Is the result actually delivering on that initial promise? So I think before we can answer that question of whether it is or not, so that's that second question I mentioned, right? Like, what is the extent of our knowledge here? Then we need to ask what these statistics actually represent. What do we really know? What are the statistics really telling us? So generally, and I always talk about statistics in my presentations, but this time I will try to keep it reasonably short, is that there's two primary types of statistics that get used in experiments. There's frequentist statistics and there's Bayesian statistics. So I'll cover them very, very briefly so we have an idea of what they mean. Frequentist statistics are about how often would an AA test how often would we see the degree of difference between control and treatment that we observed during the experiment itself, right? So this is all about error rates. So the best way to think of it is, let's say that I've run an experiment, I saw a conversion rate increase of 10%, and that was significant to a p-value of 0.05. What that really means, what that's actually telling me, is that if I ran 100 AA tests, right, control versus control, there's no difference between the two, then there would be about 5 times where I would see that 10% difference or greater due to random chance alone, right? That's what that number means. That's what I'm reporting on. And then I can make a decision on what to do with that information, whether that means that it's a real change or not. So it's all about risk management. And then we have Bayesian statistics over here on the right. So Bayesian statistics is all about inserting our own opinions into the data, which sounds kind of sketchy, but it's used in a very effectively in a lot of other disciplines, and it's using something called a prior, right? So I might have some prior belief about the data that is informing my opinion, and this creates a likelihood curve. And now I have this curve or a risk curve or whatever kind of curve you want to use, but it's some type of curve that says I have this is a 99% chance of the test being a winner or an 80% chance of the test being a loser. And frequentist and Bayesian statisticians will argue sort of back and forth over which one is better. But when I look at this, again, I have to think about the original question that people have. People want an answer to, is this the best way to make a decision for my business? Not a short-term decision, not a decision for what was happening yesterday, but a decision for what's going to happen over the next 6 months, over the next 8 months, or over the next year. And when I thought about this deeper, I came to a rather unfortunate conclusion, which is that statistical models are all about interpreting past behavior. They have absolutely nothing to do with predicting the future. And any statistician will tell you this, right? And most data scientists will tell you this as well, whether they're on the frequentist side or on the Bayesian side, right? The p-value is only telling you, based on the sample population that I have, what would my result potentially have been if I had applied this change to 100% of the users during the test period a week ago or 2 weeks ago, right? So it's over the last 2 weeks that already happened. If I had run this change at 100%, then it would have been a 5% improvement with some confidence around it. It's making zero statements, none at all, about what's happening the week after that, or 2 weeks after that, or 4 weeks after that, or 6 months after that, right? And yet fundamentally, this is kind of the problem that most business leaders want to know, right? Most business leaders, at least the ones that I've seen, don't really care about stuff that happened a week ago or 2 weeks ago. They care about what's going to happen in a quarter or in a year. And so if an experimenter was honest, it would actually lead to a conversation that would look something like this, right? So the experimenter comes to the stakeholder, they come to the business leader, and they say, hey, we have an A/B test, we ran it, and it increased revenue by 5% over 2 weeks at 95% significance. And they say, well, that's great. So that means that we're going to make $1 million over the year, right? We're going to have $1 million in our pocket. Sign the check, take it to the bank. And the experimenter says, well, the real increase is actually somewhere between 1% and 10% over the test period. You say, well, okay, well, so that's a pretty big range, right? You told me it was 5%. It could be between 1 and 10, but at least we know it's a winner, right? At least we're confident about that. Say, well, we actually don't know if it's going to keep winning at that rate over time, right? The statistics only tell us what already happened. It's not telling us about the future. The stakeholder says, but it's likely, right? It's likely that it's going to keep winning over time, right? You say, well, we don't know that. At some point in the future, this experiment may give us double the value that we saw today, or it could give us nothing. In fact, this is a very common outcome, is for the test improvement to fall to nothing. And she said, well, but directionally it's good, right? Give me something, please, give me something here. And so, well, we actually don't know. What do we know? Well, we know for sure we improve revenue by 1 to 10% over a 2-week period, maybe, right? So the question that we're actually answering with an A/B test, if it was presented honestly, is normally not the one that a business leader or a stakeholder actually cares about at all. And on the other side of the coin, you have some CRO consultants, not all CRO consultants, but certainly a lot of them, who say things like, well, we increased our revenue by 5% over 2 weeks, so we'll make $1 million annually. Yes, of course, a minimum of $1 million, right?
It could be double that.
It could be double. It could be triple. Why not? I've personally seen this many times as well. So what's the takeaway here? The questions A/B testing can answer very well are not actually the questions that business leaders care about at all. So you might be thinking to yourself, okay, all right, Chad, I got it, right? A/B tests are not great at predicting the future, but you know what? That's actually fine, because if we follow all the best practices and we run our experiments in a really, really safe way, and we focus on preventing errors and things like that, then experimentation is still always going to be a net benefit for the business. It's still going to help us innovate faster. It's going to help us figure out what's the best direction to go in for our company. So let's take a look at some of those best practices and ask those same questions before. How did we get here? And what is the extent of our knowledge actually? And this is the subject, the title of the experiment we'll start with, which is the 2-week test, right? Why 90% of your experiment shouldn't last longer than 2 weeks, and you should run your test for at least 2 weeks. So this whole idea of a 2-week experiment is very, very common in the experimentation industry. I pulled a few articles, some of them completely contradictory, about how long you should actually run your test for. And the general idea is 2 weeks is a really good barometer. So sometimes you shouldn't go over 2 weeks. Sometimes you need to go for a minimum of 2 weeks, but 2 weeks it is. And this is actually enforced by a lot of the products that exist out there as well. So these are screenshots that I got from Google Optimize, right? Tip Tuesdays, how long should your experiment run? Keep an experiment running until either 2 weeks have passed or at least one variant has 95% probability to beat the baseline. Minimum time that an experiment will run. You can set a default, and that's given to you at 2 weeks initially. When the A/B test for Google Optimize is gathering data, you don't have any data coming in yet because the compute's happening. They say that you keep your experiment running, keep it running for a minimum of 2 weeks. So this is not just enforced through articles and blog posts and things like that. It's also enforced through the actual products that we used, and I'm sure that pretty much everybody has heard this idea of run your experiments for 2 weeks just through tribal knowledge as well. So let's start with that first question of how did we get here? Why are we recommending a 2-week time period? And the answer usually comes back to customer lifecycle and representation of data. So if you're not familiar with this term of a business cycle or a customer life cycle, it basically means that a customer who arrives on your website will usually go through this sort of infinity loop style path where they visit the site, maybe they leave, they come back on their mobile device, they buy something, they come back 2 days later, they buy another thing, they recommend it to their friend, and so on and so forth, ad infinitum. And when we're running an experiment, we want to be able to capture that life cycle, at least one of those life cycles, for the purposes of representation, right? If we're running an experiment and we're only getting the first piece where they're visiting the site for the first time, then we're not actually doing an experiment on the most important data. We're not going to get that important data point of when they actually buy and return and then recommend. So that's one reason, is to capture that life cycle. And then the second reason is to be representative from a perspective of time. Right? Visitors who come in on a Sunday are very different from the visitors who come in on a Monday. And visitors who come in on week 1 are very different from the visitors who come in on week 2. And if we don't account for these differences in time, then when we actually roll an experiment forward, when we move it into production, then maybe it won't be representative of our actual customer base. And these are all things that I'd heard before, and you've probably heard them too. And when I was thinking about this, I asked that second question again. What is the extent of our knowledge? And asking that question actually leads you to several more questions, like what is our business cycle really, and how do we know that information? Is the business cycle just for one set of users? Like, I'm sure that the users who visit us repeatedly and really love our business have a very different cycle than the users who are brand new to us. Does that mean that when we're running an experiment, we should take the average of those, or not? Is our business cycle representative of anything, right? Let's say that I figured out my business cycle is actually a 3-month long period, right? That's the cycle that a user takes before we get to the end, whatever that means. Does that mean I should be running my experiments for 3 months? And then finally, what is that representative of exactly? So let's assume for some reason that the business cycle is exactly 1 week and perfectly 1 week, and that I now take 2 of those. What does that mean? What am I representing exactly? Am I representing 2 weeks in the future? Am I representing 4 weeks in the future? 3 months in the future? Am I saying that 6 months from now, because I ran a 2-week experiment, things are going to be the same? But didn't we say before that the statistics can't actually tell us what's happening in the future? They can only tell us about the past. So what's the purpose of representation? And the reality is, these sort of statistics are meant for static data sets, right? They're meant for static populations that do not change. So when you take a sample of users, let's say you take you're trying to understand whether or not students at a school are enjoying their new classes. Well, what you might do is you might take a sample of those students, 10 or 20 or 30 of them, and put them into a control group, and then take another 10 or 20 or 30 and put them into a treatment group and compare. And because that data set, which is the population of students at the school for the year, is unchanging, then even that small percentage of users, if you randomize them correctly, will be representative. But what happens when our data is changing all the time and customer behavior is changing? Is it actually representative at all? And so when you ask these questions, that leads us to another honest experimenter situation, where if we were really honest about the extent of our knowledge, we might have a conversation that went something like this, right? We should run our experiment in 2-week intervals. And the stakeholder says, well, why should we do that? They say, because otherwise it wouldn't be representative, right? And they say, well, representative of what? Say, our business cycle, of course. Oh, okay, I got it. So if it's representative of our business cycle, then that means we can trust it to keep winning over time. Well, not necessarily, but directionally. You're telling me directionally it's true, right? Well, I mean, actually, technically it could lose money next week. You really have no way of knowing that. It's like, okay, so if it could lose money next week, if we don't know what's going to happen, then what's the point of it being representative in the first place? Like, oh, well, it sounds good, sounds scientific. And so we're back to our consultant, right? So we should run experiment in 2 weeks. Why? Well, that's because if it's a winner over 2 weeks, then that means it's going to win. It's going to win forever. And that sounds ridiculous, but this is something that I've heard normally, and I think that people can often get into this trap when we're talking about the 2-week experiment, as if the 2 weeks actually means something, if it represents something. And maybe it does, right? To extend an olive branch, maybe running a test for 2 weeks is truly representative, but until you measure that and you know if it's representative or not, it's kind of a toss-up, right? So these are all comments. Normally when I talk about things like this, I get a lot of pushback, understandably so, because this is how people have been doing things, right? And these are the kind of comments I get. Well, we have to start somewhere, right? If we want to run A/B tests, and it's really, really hard to figure out like exactly how representative our data is. So why don't we just start with 2 weeks? Like, why shouldn't we do that? It's also an easy number to remember, and it's also a really good barometer, maybe, probably, I don't know. And sure, it's not perfect, but you know what? It's better than nothing. It's better than just doing this sort of randomized peaking and then we stop at a bad time, right? At least it's better than that. And I think this brings us to sort of an existential question about experimentation, and specifically about this 2-week time period. What are we trying to gain from running it over 2 weeks, really? And the answer is, we're trying to make a prediction, right? if we run our test over 2 weeks, we believe with some moderate amount of confidence that is going to continue winning into the future. So that 2-week mark, the metrics that we observe at 2 weeks, we are actually making a makeshift prediction about the future, although that prediction is actually based on no evidence because we haven't actually measured it. So if our goal is to make the best prediction possible, which is currently how we're using the 2-week threshold, then that makes that 2-week threshold completely meaningless if we find a better predictive metric earlier. So if I have a metric that I say can be a better predictor than the 2-week metric mark, and I can find that at 30 minutes into my test, or a day into my test, or 2 days into my test, then I should be using that instead of the 2-week metric, right? Okay.
Let me ask you a question. I want to reframe it, make sure I get it, because this
Sure.
somebody asked me. So what you're saying is the reason for testing in weeks, and ideally 2 weeks is what the industry standard is, so that we have this representative sample that will be predictive of how the population as a whole will behave in the future.
Yes.
However, the statistics that we're using aren't forecasting statistics. They are historical look back statistics that help us understand what happened, not what will happen.
Correct.
Therefore, having a representative sample helps us better understand what happened, but it doesn't do anything to help us understand what will happen.
Exactly. Okay, so maybe we say all that, right? Maybe we say all that, and you're still not convinced. Maybe you're saying, okay, Chad, but that's cool, that's fine. All right, so maybe we can't make predictions, but that doesn't mean that A/B testing in the way that we've been using it is bad, right? It's still super powerful for innovation, right? It's good for finding the right direction, finding the right things to optimize for, and building on top of that and iterating, right? It's all about iterating and moving away from things that we can't measure or don't know how to measure. So let me ask you a question there. How many of you have experienced websites like this on mobile? So I'm using an application or I'm using a website and I'm really enjoying the content, and then all of a sudden I get a pop-up, view Reddit in the app because you deserve the best, but apparently I don't deserve to just keep looking at the content that I was watching without problems a second ago. And then it has this tiny little, or go to the mobile site. You mean where I am right now? Type of text at the bottom that's really hard to click with my thumb. Or even worse, on Quora. I don't know if you guys have ever seen this one. This might be one of the websites I hate the most to visit right now. I used to go there all the time. I barely go there anymore at all, and it's exactly because of this application. Let me ask you a question. Do you see a way to get rid of this pop-up? Where is it? Where's the X?
Oh, wow. Just
The
down
answer,
that's it.
that's right. It's nowhere. There is no X. You cannot get rid of this pop-up. The only way that you can get rid of it is to click the download the free app button. And it's the same thing for the Yelp app as well, right? Want to see all 39 photos from the app? Well, your only option, the only thing that you can click is to either go back, click the little Yelp logo, or to click the giant green button in front of your face, right? I see these type of experiences all the time. All the time I see them, these sorts of really annoying prompts that are motivating me to download or buy or do something else that I don't want to do. Why is this happening, right? I didn't see these a few years ago. Where are they coming from? Well, I can speak from personal experience when I say that they are probably the result of A/B test results that look something like this,
Sure.
right? You've got 4 metrics, app downloads that increased by 8%, and it's significant. It's great. It's green, right? Revenue doesn't really move significantly, and so that's fine. Visits doesn't really move significantly, so that's fine. And yeah, sure, people sharing our content, that's down significantly, but the app downloads is up. And as a product manager on the app team, this looks great to me. I love this. And so to me, this test is a win. Now, how many people would still consider this test a win if the long-term metrics look something like this, right? So sure, our downloads per year, it jumps, user satisfaction drops by 10%, that's significant, retention drops by 6%, and yearly revenue, not weekly revenue, right? Not revenue over 2 weeks, revenue of the year is down by 5%. And you might be saying, well, how would we know this information? How would we know downloads per year or satisfaction? And every single one of these metrics is a predictive metric. It's a true predictive metric, right? It's looking at the current state of the experiment and predicting, based on what we see, where we would be a year from now. And this is something that is incredibly, incredibly difficult to do, but people are making decisions based on these metrics, not on these metrics. And so it's completely possible that an experiment that wins over a 2-week period could certainly lose over the course of the year as people get more and more frustrated with things like a pop-up, but we've made the assumption that it's winning and that it's going to win in perpetuity. And so if you're asking how can an experiment actually damage a website, it can damage it through ways like this. Another problem that I've observed with this whole idea about innovation is the novelty effect. Now, most people know about the novelty effect. If you're not familiar with the term, it basically means when we've run an experiment and the metric changes during that time period, but then it sort of falls back to baseline, right? It's something that people got really excited about and they clicked it because it was new and different. But then after some period of time, it just disappeared, right? That impact disappeared. And I remember the very first test, the very first experiment I ever ran at Subway was exactly like this. We changed the call to action in the top right part of the screen. We changed the color from green to red, which is a super stereotypical experiment, or green to yellow, actually. And we got a 5% improvement in revenue, a 5% improvement in revenue. And we were all super excited. We did the test exactly right, ran it over a 2-week period, and then a month later, we decided to do a reverse flight. So that's where we ran the control as that new experience and ran the previous control as the
And it won
treatment.
again, didn't it?
Uh, no, it did not. Uh, there was actually no change at all. So
Wow.
most people, again, are aware of novelty effects, but they don't do anything about them. They don't talk about how they can solve them. They don't do reverse flighting so that they can check. And there are even some experimental platforms that take short-term novelty effects into account, but how short-term is actually okay? Is 1 week fine? Is 2 weeks fine? What if it drops to 0 after a month? What if it drops to 0 after 6 months? Is that okay? Especially if our reporting is still annually, if it's still over the course of the year. So imagine if you're a product manager and you're consistently optimizing for novelty effects. So you're moving away from those high impact wins, things like improving the customer experience that you might not see the impact to for 3 months as people start to use your product and understand how that feature works. You could be swiveling away from that to focus on these short-term wins that are basically all novelty effects. So when people say, well, experimentation helps us with innovation, the question I ask is, how do you know that? How do you really know you're helping? If you removed experimentation completely, would the product be in a better place or not? That's a question that you should be able to answer, and most people can't. So to summarize what we just talked about, short-term metrics, they cannot predict the future. They cannot. We have no idea if a 2-week experiment, if the metrics are predictive or not, until we take the time to measure it, and that's actually a really difficult thing to do, but generally we have no clue. Short-term experiments based on short-term metrics can actually harm a business. You can be focusing on improving something like downloads, like that experiment I showed you, at the expense of long-term metrics. And again, unless we have some way of measuring the long term, we actually have no clue if we're innovating in the right direction or if we're introducing incrementality into our websites and making the customer experience very bad. So I've now presented this picture of doom and gloom, right? Like everything's
Say,
horrible.
a little grim, Chad. Bring us back.
Yeah, everything's bad. So I do have some recommendations on how you can fix this, or at least how you can maybe change your thinking about something like this. And the first thing to do is to demand accountability. That's accountability from experimentation tools, from internal platforms, from third-party tools, and also for teams that are working on experimentation. So
And
what am
from
I?
consultants.
And from consultants, yes. So what do I mean by that? Well, most teams and most platforms use what I call platform metrics. So we judge ourselves, we judge the quality of a work based on how well people are using our platform, which might be an internal tool, it might be an agency, it might be a third-party platform, right? How many experiments have we run this quarter? How many experiments have resulted in a conversion rate improvement? The reality is that these are actually not value-driving metrics, right? There is nothing that says the experiments have done are actually making the business better here. What's an example of a value driving metric? How about the amount of money that we earned as a result of our experimentation platform or service, or the amount of money that we saved? And the pushback I always get when I bring up these sort of dollars and cents metrics is, hey, it's really hard. Measuring our impact is really hard. And that's absolutely true. And I don't disagree with you. It's something that I have struggled with personally at every organization that I've worked for. I do have some tips on how to do that coming in just a second, but I think the fundamental point to understand is if measuring our own long-term impact is hard, then it's kind of bizarre that we're telling people to do that themselves. We're telling UX designers with these really big experiences that they need to measure to the exact dollar and cent how much value their experience provides. If we can't do that, right, it's a little hypocritical, I think.
And one note, Chad.
Yeah.
Next TLC conversation on Thursday, March 12th, Tom Westling is going to help us figure this out as well. This very challenging question.
Awesome. Yeah, that's great. So the next, Yoda, one of my favorite characters in cinema, do or do not, there is no try. What am I talking about here? Making predictions, right? So we talked about using 2 weeks as a predictive metric, like a pseudo predictive metric. If we're going to go that route, we should just make real predictions. We should make actual predictions. So we can do that using holdout groups, right? Or reverse flight. So these are ways of basically checking to see how our experiment is doing over time. If it's still a winner, we can use that data to build an experimental metric. Although I will warn you, and I will tell you that is very data science intensive, right? If you're just working with a few engineers or maybe an analyst, it's hard to build a good predictive metric and a good predictive model. But if you do it, it should be trained on previous experiments. Your previous experiments should be used as training data for this model, and you should be able to validate it over time. That means you should be able to go at some point in the future, look back at the predictions you've made, ask yourself, are these good or are these bad, and adjust accordingly. And if the response is, well, that sounds like a lot of work, it sounds like a lot of resources, I don't know, or I don't run enough experiments to be able to do that, then guess what? You should stop making predictions. Stop using the 2-week metric as a prediction of something else, right? That's the Yoda quote. Do or do not. You either have the ability to do it right, or you shouldn't do it at all. So if you're not able to do it all, then how should we be using experimentation? What is the value of A/B testing? I've done a presentation on the value of A/B testing before, and I think one of the key components of it is to look at experimentation as if it was insurance. So if you bought some insurance, how would you justify the ROI of that insurance? Well, the answer is you wouldn't know until you got into an accident what the ROI was, right? Once you got hurt, maybe I fall down some steps, I break my leg, I crack my head open, and I'm sitting in the hospital, and I have to pay $500 or $1,000 for a copay. But if I didn't have insurance, that would have cost me $50,000 or $25,000. The difference is the amount of money that I saved, right? We can actually do the same thing in experimentation. If we focus on stopping bad things early, things that we know are bad, right? Features that have bugs, features with super high latency and a really high error rate, high number of 400 errors or 500 errors, performance drop-offs in terms of business metrics, revenue falls off a cliff because the experience is broken, or some customer action falls off a cliff because the experience is broken. If we focus on stopping these things for all the features that goes out, so it's focusing less on, hey, let's do an A/B test to improve this functionality or that functionality. If instead the focus is, let's make sure that all code deployments are not breaking anything, then we've built a really, really healthy guardrail right? And this is starting to look as experimentation as a part of CI/CD. So this is continuous integration, continuous deployment. If you're not familiar with that term, it's basically the way that software developers deploy code into production, usually in an automated way. So personally, I see experimentation as an extension of CI/CD. It's just checking the value and the validity of our deployments, whether or not they're breaking or losing money in a production environment. And anybody can do that, and anybody can do that for every experiment. So then if you care about things like number of experiments run, you're going to take that number from 2 or 3 up to whatever the number of deployments you have. And in some cases that's hundreds a month, in some cases that's thousands a month. And if that sounds sort of terrifying and daunting, like, oh no, what is the value of A/B testing and experimentation if I'm just using it as a guardrail? You should actually see that as a freeing thing, right? Because basically what we're saying is focus on the customer experience. Don't focus on being able on measuring to the exact decimal point in a 2-week period how much money this thing's going to make, unless you're really, really confident about how much money it's going to make in the year. It's kind of a wasted exercise. So you can focus on things like improving the customer experience and making sure stuff is not breaking, which opens up what you're doing. It actually doesn't limit it at all. So that's the end of the presentation. Thank you for sitting through that. I know that was long. It was a lot of information. And Kelly, thank you for having me on. I appreciate it.
Of course. So I have some questions that folks have not wanted to ask everybody else that they've asked me. One of the first ones is around the difference. Let's see if I can translate here. When you're talking about experimentation, you're specifically talking about hypothesis testing, A/B testing, split testing, correct?
Yes.
Okay. So this person is asking, how does your views on experimentation for the purposes of insurance compare with your views on optimization using a bandit or machine learning algorithm to actually make improvements and keep them on?
Yeah, I think it's I don't use bandits that much personally. It's actually really complicated to figure out exactly how much value a feature that's been running for a very, very long time has made compared to a counterfactual. I see that as a slightly different problem that I don't have a great answer to. I think in this case I'm mainly focused on sort of your traditional A/B testing. We run 2 features over some period of time and see what the result is. People like Matt Gershoff could probably speak a little bit more about like multi-arm bandits and understanding the ROI of those.
Cool. And then a question around using A/B testing not to predict, if you're not going to use it for calculating runtime, or not, sorry, impact, but you want to use it for making better decisions about your product. So for example, you have a new product coming out and you're trying to iteratively test into different elements of the feature to figure out which one works best historically, with the end result hopefully being a better designed product. What do you think of that use of experimentation?
I mean, it depends on how you're defining a better designed product, right? Like, is the product that's better designed necessarily the one that's making slightly more money over a 2-week period? Right? If you go and talk to any UX professional about what better design mean, one thing that they will tell you usually pretty adamantly is the things that make a design really great are usually not the things that we can measure through instrumentation. The things like, I've enjoyed this experience. I'm going to recommend this to a friend of mine because I think it's great. I'm going to be happy when I use this, right? Those elements of design that I think is kind of the core of design is usually totally left out in sort of the business metrics that we can collect from like monitoring systems. So I think that's the big question that you have to ask yourself is the data that I'm collecting going to actually be informative of what a good design, right, of improving customer experience and what a good design actually is? In my experience, the answer to that is no.
And so that's really interesting because we've had a couple of talks in the past to Paula Sappington, Els Aerts. A couple of people have chatted about the value of qualitative data for better understanding that customer experience impact of your design decisions or your experimentation decisions, your product roadmaps. It sounds like almost you would say use A/B testing to validate decisions that you've made as an insurance, and maybe use qualitative to make those decisions up front.
Exactly. Yep. That is that's exactly what I believe. I think that there are certainly, especially when we get into things like machine learning algorithms, there's a lot of value in running A/B tests as long as we have some predictive tool to understand what our real impact over time actually is. But if you're talking about improving the customer experience, sometimes I hear people say that like, I've made the customer experience better through A/B testing. I always question how people have actually done that. I'm not sure what customer experience metrics they're referring to. Because usually the only instrumentation you can get from a product is like whether or not they bought something, whether or not they converted. So you might try to make a logical leap between they bought something more frequently, so that means we improve the customer experience.
But if we pull up the example of the app downloads on your mobile
Right.
phone, and we only gave them one way to move forward, which was to download more apps, that is absolutely not a correlative to a better user experience.
Right.
Does anybody else have any questions? If you guys want to add them in the Slack or take yourself off mute, you're welcome to do so. Corey says, I think you likely save more money automating the build, deploy, testing process in a given year than running A/B tests, because when you have downtime, you make zero money. So I see testing as complementing the process.
Yep, I agree with that.
Let's see, Ben LeBay says, opinion on testing tools that lend themselves to CI/CD programs compared to traditional marketing testing programs. For example, would you recommend Optimizely, SiteSpect, internal tools? We can name several: Conductrix, Split, Target.
So I will go out, I will say for the record that I am not endorsed by any tool. I am a practitioner, so no one is paying me to say this. I would say for the money,
that's why I asked you, Chad.
Okay. Thanks, Ben. If I had to, generally I'll go with an internal tool, because I think that the use cases are usually so different that it requires a lot of customization. But if I couldn't go with an internal tool, and there's a lot of reasons why you might not be able to, resourcing for one, I would choose Split. I think Split is probably the most advanced A/B testing tool in terms of how they're thinking about the value that experimentation brings. I think they're very, very closely aligned with that guardrail framework. Or if they're not 100% aligned there, then I think, based on what I've seen, that they're moving in that direction.
Yeah, they're very much so. First and foremost, a developer-centric, engineer-centric, feature flagging, measuring the impacts. I think that's a really good analogy of saying that they're focused on the guardrails.
Yeah.
Tim would like to introduce a hashtag Chad rolled phenomenon, taking vendor videos promising the moon and then 2 minutes in cutting to a video of you on this call.
Okay.
I think that's a good idea, Tim. And Corey says, anything server side you can build into the pipeline by mocking the calls. On client side, it becomes trickier because of how client side testing works, which is true.
Yep.
Anybody else got? But I can take one more question. Looks like you might be writing something. While you type, I will remind everybody we have 2 more calls already on the schedule. It's split.io, Kano. He says it's poor name choice, which is a good point. If you just type split in there, you're gonna have a hard time finding them. Next call is on a Thursday, and it will be, Tom Westling, and he's going to talk to us about program ROI and how you calculate it safely. and using the appropriate statistical methodologies to minimize your overcounting and reporting so that you don't become one of those people that they tell you to get out of my office. And then after that, Corey Underwood is going to share with everybody all the impacts of all these changes that are happening on the interwebs with the browser changes and the privacy laws and all the implications that those have. And he's going to answer all your questions. I've actually had 3 people ask questions in the last 2 days that I've sent your way, Corey. So people are probably going to start chatting with you before that call, but expect lots of questions and feedback. And I'm sure there's a lot of you that were on this call that are thinking, oh my gosh, what am I doing? And you're having some personal crisis. And I'm going to give everybody Chad's personal phone number so you can start sending some text messages so you can have a great Valentine's night. But no, seriously, post your questions in the Slack and we can all have a conversation, because I think this is important content. And I really appreciate you sharing it with us and being a risk taker, coming out there and telling everybody their jobs are without value. No, I'm just kidding. We love you, Chad. All right. Thanks, everybody. I'll see you next time, March 12th. And take care. Happy Valentine's Day.
Bye-bye.
Bye.